Now that we have learned how to solve quadratic equations, square root method, factoring method, and quadratic formula, we're going to start to tie that into what do those answers mean as far as a graph goes. And we're going to also talk about, some terms about a quadratic graph, and then also how can I actually solve an equation by graphing it or by looking at its graph. So you guys have worked a little bit with quadratic graphs in trimester 1. All you had to do in trimester 1 is categorize, is this graph linear, exponential, or quadratic? So you've seen this shape before, but you haven't had to analyze it and really interpret it. So we do know that a quadratic equation is f of x equals ax squared plus bx plus c. And just remember that f of x is just like a y equals. It's just function notation. Okay, so nothing different than a y, just another way to write it. All the graphs of quadratic equations are called parabolas. So on a parabola, that's the U shape that we get, not a V. V is absolute value. Okay, this would be a U shape. So they can look one of two ways. They can open up or they can open down. If they open up, they look like a smiley face. And that would be considered a positive parabola. The way that I remember it is smiley face. You're in a positive mood. That's a positive parabola. And you can also look at the equation if you have it and say, hey, if your A is positive, then you have a positive parabola or your graph is going to open up. The other direction is it could open down. So it looks like a frowny face. That would be a negative parabola. And the way that we can find that, if you have the equation, is that your A is negative. And the A, right, is the coefficient of your x squared, just like it was with quadratic formula. No different there. Okay, so that's the directions it can open up and its general shape. Now let's get into some vocab for it. So you've got this picture to your right that's color-coded, and I'm going to try to do the same definitions in the color code to kind of really help you out. So I'm going to go to green. We'll do a darker green so you can see it. So a y-intercept is no different on a parabola than it is a linear function. It is where the graph crosses the y-axis. Okay, and the coordinate point of every y-intercept is 0, comma, and then the number of the y-intercept. The reason the x is 0 because at any point on the y-axis, it didn't move left or right from the origin. So it moved 0 left and right from the origin and then only went up or down. Make sure that when you are listing the y-intercept, you have to have parentheses around it. If you don't have parentheses, that's not a coordinate point. That's only a list of numbers. So make sure you have the parentheses and the comma in between. Okay, an x-intercept. So I have that in red on my graph. And very similar to a y-intercept, an x-intercept is where the graph crosses the x-axis. So in the graph here, you can see you actually have two x-intercepts because of that the U shape. It crosses the x-axis in two places. Sometimes it'll only cross it once, which we'll get into here after a bit. And sometimes it doesn't cross the x-axis at all, so it doesn't have any x-intercepts. When we write these as coordinate points, these are on the x-axis. So you would have a value for the x but then your y value is 0 because you didn't go up or down any. You went only left or only right and then stopped. Okay, so those are terms that you should be familiar with. The next one is a new term, a vertex. And in the graph, you can really see it labeled. The vertex is the maximum or minimum point of the parabola. And, how do we tell if it's a maximum or if it's a minimum? I kind of think of it as you're riding a roller coaster. So I'm going to draw on the graph, as you go, you're going up, 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 up on the roller coaster. And then you get to the very top and now you're going down. So at the top, at the vertex, that's the maximum height. That's the highest that that roller coaster is going to get. So in this particular example, that is a maximum. We'll go through a couple of examples about minimum as well. All right, last one on here is called an axis of symmetry. So symmetry, if you think about what does it mean to be symmetric? Symmetric is a line that cuts an image in half, and it's the exact same thing on both sides. So with the parabola, we are able to cut it in half as well. So that would be a line that cuts the parabola in half symmetrically. Okay, so that was not on this graph, so we're going to draw it on here, and I'm going to make my line much thicker. The line that would make this cut in half vertically would be this line right here. And we represent it with a dashed line because it's not part of the graph, but it is a line that we want to recognize. Okay, so that would be the axis of symmetry. Now, we're also going to be asking you for the equation of that line. Now, that is a vertical line. So every vertical line, when you write the equation, it is x equals whatever x value that it crosses through. So like on our example, that goes through +1, so that would be x equals 1, would be our axis of symmetry. Okay, now we have domain and range. So we have played with domain and range before, but it has been a little bit. So we want to touch base on it today, and we'll be coming back to it in a couple days as well. So domain describes how does your function behave as you move left and as you move right. So on a parabola, whether it's facing up or if it's facing down, as it goes up forever or down forever, it's also going left and right forever. Right here, there's arrows on the end of this. They're going to always kind of be implied because it's hard for us to get arrows on some of these graphs. So even as this goes down on the left-hand side, it's also going left, little by little by little. Same thing with the right. As it goes down, it's going to go to the right, little by little by little. So there's nothing stopping it from going left and right forever. Same thing would happen if this were facing upward. Okay, so there's a couple of ways that we can describe it. I can say that it is all real numbers. And I think first trimester, some of you guys learned the symbol. It's like an R with an extra line in it. Okay, and then we also learned interval notation, and that would be parenthesis, negative infinity to positive infinity. That means I go from negative infinity to positive infinity on the x-axis. There is nothing stopping me from using every single x value in existence. So range. Range on parabolas does have limitations because we have a vertex that's a maximum or a minimum. So your range describes how your y values interact. And what you want to do is you really just need to pay attention to how does it open and what's the vertex, okay? So for here, if you look at the graph, let's see, I'm going to make my line thicker. I don't go any higher than that orange line I just drew. I do not go above it. So if I am going to describe the range for this example, I would say that my graph touches every y value less than or equal to, and let's see, that line goes through 1, 2, 3, 4 on the y-axis. Okay, now that is inequality notation. We also learned interval notation. So we are allowed to equal 4, and this is going down, right? The parabola is going all the way down, it's going negative. So what I would do is I would describe it as, well, I go towards negative infinity, but then I go no higher than 4. And because I can equal 4, I have a bracket, not a parenthesis. The infinities have a parenthesis because I can never equal infinity. I can only approach it. So anytime we can equal it, we have a bracket. Now, the other thing is, in this example, we were going down forever. So the negative infinity is written first. In the interval notation, the smaller value is written first. So we're going to go through some examples where the infinity is going to be on the right, not the left, and we'll kind of explain why. So let's quickly go through some examples just real quick, and we're just going to identify pieces of these graphs. So for this first one here, what's the vertex? Well, the vertex is right here. And what would those coordinates be? That would be the coordinates -1, 4. And again, you have to have it in parentheses or it is not a coordinate point. Okay, is this vertex a maximum or a minimum? Well, again, think about the roller coaster. I'm going up, 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 up the roller coaster, and then I get to the peak, and then I start to come down. So I reach a maximum height. Is this a positive parabola or a negative parabola? Well, I'm facing downward, look like a frowny face. So this one would be negative. What's my y-intercept? So if I look, my y-intercept is where do I cross the y-axis, which is right here. And what are the coordinates of that point? Well, I went left and right, none. So that would be 0, 3. Now roots. Oh, this is what I forgot to talk about. I'm going to scroll back up for just a minute. So we've got lots of stuff in for our x-intercept. Let's do this. I will talk about it as we go. X-intercepts have lots of different names. And depending on the situation, we call them lots of different things. So your roots are also your x-intercepts. Roots, zeros, x-intercepts. Those are all the same thing. Okay, so you'll see us kind of use those terms interchangeably. So what are the roots of this? That's asking what are your x-intercepts? Well, this graph has 2. It has one at -3 and one at 1. So you would write out those coordinate points. That is -3, 0 and 1, 0. Those are my 2 x-intercepts. Okay, my axis of symmetry. Remember, that's the vertical line that goes through the middle. And if you guys have caught on, the middle is always going to go through that vertex. Okay, so what is the equation of that vertical line? It's vertical, so that's x equals -1. All right, so now we're to domain and range. So for these, you again have to think about domain is how your graph is reacting as it goes left and right. Little hint is domain on parabolas is always all real numbers, because with that U shape, you have nothing to stop the graph from going left and right forever. As it goes up and down, it's going to go in both directions. So you can say from negative infinity to positive infinity, or all real numbers. And I'm running out of space, so I'm going to abbreviate numbers. Now for your range, I have a maximum. I'm not going to go any lower, or I'm sorry, any higher than that line right there. And I'm only going down from there. So which means I use all y values less than or equal to, on this case, that would be 4. Now on Canvas, you're going to see it in interval notation. So if I'm going less than 4, I am approaching negative infinity. So I would notate this as negative infinity to positive 4, and I'm able to equal the 4. So I have that bracket. Okay, if domain and range, especially range, if that's feeling really weird to you right now, it's okay. We're going to be spending lots of time on it because it is kind of an abstract thought. Okay, next one, number 2, vertex. So vertex would be right here. That's the maximum or the minimum point. And its coordinates are -1, 2. Is it a maximum or minimum? Well, think about it again. If you're riding the roller coaster, you're going down, get to the bottom, and then you go back up. So you have reached the minimum of the graph. That's the lowest you're going to go. Is it a positive parabola or a negative parabola? It is positive because you got a happy face. Okay, y-intercept. We are right here for crossing that y-axis, and that is the coordinate point 0, 3. And then what are the zeros? Now remember, zeros is another name for x-intercepts. So what are your x-intercepts? We don't have any. This graph does not touch that x-axis whatsoever. So when you don't have any x-intercepts, you can write none, and that's fine. Make sure you don't put 0, because then it's going to sound like you cross the axis at 0, but we don't for this one. All right, axis of symmetries. Remember, that's the line, that vertical line that cuts the parabola in half, and kind of gave you the hint earlier of, hey, it's always going to go through your vertex. So what is the equation of that line? This would be x equals -1. Domain, as stated earlier, it is always from negative infinity to positive infinity, or all real numbers, because there is nothing stopping that graph from going left forever and right forever. Range. What is the range going to be for this one? So I'm going to draw in that line again of, I don't go any lower than that orange line right there. So I would write this as my y values have to be greater than or equal to 2. Now to put that in interval notation, I am going up forever. So that is going to positive infinity. Because I'm going to positive infinity, that is a much larger number than positive 2. So for interval notation, the 2 will be written first, and it has a bracket because you can equal it. and then it's going to positive infinity, but that would have the parenthesis because you can never equal positive infinity. Okay, next what I want you to do is I want you to pause this video and I want you to try number 3 on your own. Feel free to look back at your other examples, but I want you to try it on your own. And after you're done, then play the video again and you can go through the answers that I'm about to write out. Okay, so the vertex for this one is right here, and that is 3, 0. That is a maximum point. This parabola is negative. The y-intercept is all the way over here at negative 18. So that is 0, negative 18. The x-intercepts. Well, if you notice on this one, there's actually only one. It happens to be the same as your vertex. So in this case, you only have one x-intercept, and it happens to also be your vertex. And little hint, every time you only have one x-intercept, that point is also your vertex. Okay, axis of symmetry. So if we draw that vertical line in of what would cut this parabola in half, and then that equation would be x equals 3. All right, domain and range. Domain would be all real numbers, which is negative infinity to positive infinity. And then your range. So again, if I drew a line that I don't go any higher than, that line happens to be my x-axis. The equation of that line is y equals 0. So I am less than or equal to 0 for all the y's that I use. And in interval notation, I'm going from 0 to negative infinity. So the negative infinity is the smaller of the two numbers. 0 is the larger, and I can equal 0, so that has a bracket. Okay, main idea coming from today is that you can identify all the parts of the quadratic graph. Domain and range, it's a process. It's not something that you might understand immediately. Hopefully some of you at least kind of recognize it and can start to build from there. All right, so now let's go our last method of solving. On here, solve by graphing. We can use that if we have the graph. And so on here for number 4, all you have to do for solve by graphing is it's your x-intercepts. So on number 4, I have an x-intercept here and here. So when you tell me what x equals, you're just telling me my x-intercepts. So the solutions to this is x equals negative 0.5 and 2.5. And that's it. If I already have the graph, that's all I have to do to solve it by graphing. Just super easy and super nice. It's even easier than the square root method. On 5, looks like we're going to have to do a little bit more estimating on here. So my x-intercepts would be here and here. And so I would estimate that it's between 2 and 2.5. So I'd say x would be about a 2.3. And let's see, between 5.5 and 6, so maybe a 5.7. And those would be my 2 answers. Okay, 2 more to go. On 6, so I only have one x-intercept. It's right there at 0, so my answer is just x equals 0. I only have one answer there. You guys saw a lot for the first half of this chapter that sometimes you can have two solutions, which is most of the time you have two solutions. Sometimes you only get one, and then sometimes you also have none, right? You get a no solution. So which brings up number 7. Notice number 7, that graph doesn't touch the x-axis. So it doesn't have any solutions. I can't write x equals a value because this parabola does not touch the x-axis. So solving by graphing, this one would be no solution. Okay, so again, I would be writing your own notes for these. If you can identify pieces of the parabola and be able to solve by graphing, you're in good shape. Domain and range takes a little while. Don't worry about it. Still try. You're going to have a couple questions on it when you get to the homework for this. But it's a process. So cut yourself a break or conference your teacher and ask for help because it is kind of an odd abstract thought.